Here in pre-algebra, we are moving on now to the part of the unit where you will be able to use a calculator. We're going to be talking about some different formulas, things like that. Colin, start making your help sheet now. Okay, all these formulas should go on a help sheet, and if you start to make it now, it's going to be less work when the time comes. If you're looking for a pencil sharpener, I actually don't have one in my room. They don't give me one. So you can go to this. Or Mattis has got one. Or Liam is. Thank you to all of you. So these are the types of situations that we're going to use this formula for. It says. We are going to find a new amount after an increase. Okay, folks, I'm at 3, 2, 1, you are quiet. Okay, we're finding a new amount after an increase. For example, last week you ran 20 miles, and this week you plan to increase that distance by 15%. How many miles will you run this week? You buy an iPod off eBay for $125 and will resell it with a 30% markup. How much will you be selling the iPod for? Your bowling score was 180 and your goal is to raise it by 45%. What score are you setting as your goal? Okay, so we're starting with an original amount. We're increasing it by a percentage. And our interest today is to find what that new amount is going to be. Okay? And there are two methods that we can do this kind of with CO23. We're talking about multiple ways. One way to do it is by finding the amount of increase first. Okay? And if we are increasing, this is the situation here. We're increasing 20 by 15%. Okay? To find the amount of increase first, we want to focus on this 15%. We're asking ourselves here, what is 15% of 20? Okay? Because we aren't increasing this by 15 miles. Right? It's a percentage, 15%. The amount of that percent is going to depend on the whole, what we originally start with. And so you can look back to CO23, and there were 3 different methods we talked about to find 15% of 20. You can use fractions, you can break it down into 10%, you can use the multiplication method. Either way you want to do it, what do we get? Who's got 15% of 3 or 15% of 20, and be prepared to explain how you found it. Flip back a page and look at those different methods that we used. Jeffrey, you need to have a piece of paper out then, so you can take notes as we go along. If you don't have the binder with you, then you are still responsible for taking the notes. What do you want to do? All right, let's use fractions, okay? 15% of 20 as a fraction is 15 over 100, right? Write that as a fraction of or times 20 over 1. Blake? 3 is the answer, okay? So finishing this out here, 15 times 20 is 300. 100 times 1 is 100. And 300 divided by 100 equals 3. Right? That's the fraction method that we use. There are others, but since no one wanted to give me one, I just picked one. Yes, John?
I need one more time to write that down.
Go ahead. Okay? Yeah.
What happens if the fraction is uneven?
Then you might want to use a different method, which is why we have the calculator available to us. Okay? So now, does that mean that next week we're running 3 miles? Is that what we just solved for here? No. What does it mean? What does it mean?
That 15% of 20.
So 15% of 20 is 3. And what does that 3 represent? Wyatt?
You're going to add 3 miles.
That's the amount of the increase. Right? So once you get this, your final step is go back to the original amount, which is 20, add the increase to it, and next week we'll be running a total of 23 miles. Okay? So this method is only finding the amount of the increase. We then have to add that to the original. Okay? There's a shorter way that involves finding the new total directly. And here's where the formula comes in. The formula for this is the original amount, okay, which in our case is what? What's our original amount here?
20.
20. That's what we're starting with. Okay? I'm going to put a 20 right below that. Okay? And we multiply that by 100% plus the, well, we'll call it the percentage. Okay? And we're going to think about this in terms of decimals. What is 100% plus 15%? And where did the 15% come from? It's the amount of the increase, right? So if you want to replace that P% with maybe INC for increase, you know, if that helps you kind of remember what we're plugging in there better. INC isn't really a variable, but it can represent that increase there. 100% plus 15%, I heard someone say is 115%. Okay? What's 115% as a decimal? What's 115% of the decimal? Jeffrey?
1.15.
1.15 or 1.15. You can use your calculator here. What is 20 times 1.15? What is 20 times 1.15? Tony. 23. Does that 23 look familiar? Yes. Okay. We got to our new total directly. We didn't find the 3 first and then add it on. We got there directly. Can anyone see what in this formula causes that to happen? Okay. This 100% right here represents the whole original amount, right? It represents that 20. So when we multiply 20 by 100% plus 15%, you know, 100% is one whole. If you multiply 20 by one whole, what do you get? 20. So the purpose of this 100% is to give us our original amount back again. Okay? We are multiplying 20 by 1, and then 20 by the increase, by that 15%. What it does there is this 115%, you'll notice it's greater than one whole. As a decimal, you'll see it's 1.15, again, greater than one whole. This whole of 1 gives us the 20 back, and the 0.15 adds on to that 3, the 15% for us. Okay? So this way finds the increase amount first. We have to add it to the original. This formula does it for us. So it's kind of nice. Kind of nice. You've seen one example of each of them, so I don't expect mastery, but any questions as to how I got something at this particular juncture? Yes?
I did the iPod one.
Yes.
And I got 1 instead of 8.
What was the iPod situation? You bought it for $125, and what's the markup?
30%.
30%? Okay. So for the iPod, we're essentially increasing $125, the original amount, by 30%. Right? What method do you want to use for this one? Fractions, 10 percentages, 10%, or the multiplication method? Okay? Multiplication method. Right? So we essentially want 30% of 125, right? That's what we're looking for here. Using the multiplication method, what would we multiply? What would we multiply?
3 tenths by 125 over 1.
So that would work. That's more of a fraction way. Okay, that's using fractions. Using the multiplication method, what would we multiply, Cade?
3.0 times 1.25.
Close. it'd be 3.0 times 12.5. Okay, because remember you move the decimal over once in each of them. So 3.0 and 12.5. What do we get? What is 3.0 times 12.5? Yes, Shay.
37.5.
37.5, which in the context of our question represents what? 37.5, but in the context of our question represents what? Yeah.
Oh, 162.5.
So that's the final answer, right? But what does this 37.5 represents? What?
$37.50.
Money, right? So we do want to put the zero here because it is talking about dollars and cents, okay? The context there. What Blake said about using the fraction 3/10 times 125 over 1, you should have gotten the same answer.
I got 1 7/8.
1 7/8. How did you multiply this?
I multiplied across, and then
Okay.
I got 375 over 200, and I.
So where the 200
And I
comes from?
simplified
So the 375 is right, but 10 times 1 is just 10.
No, 3 times 125.
Yep, that equals 375. But then you said you got like 200 on the bottom.
200, and then.
Where did the 200 come from? It should just be a 10 times 1, right?
Oh. Yeah.
Yeah. So wherever you got the 200 from, take a look at your numbers. But what you said was absolutely correct. But then that 10 times 1 would just be a 10, which 375 divided by 10 gives us that 37.5 there. Lexi gave us the final answer. This only represents the amount of the markup. You've got the original price. I mean, you would not buy an iPod for $125 and resell it for $37.50. That would be not good business plan for you. You want to increase it by $37.50, and your final selling price is $162.50. Okay, so again here we're finding that increase first. What is the markup? And then adding that to the original price. Using our formula, the new total directly, we've got original, right, which is what? 125, okay? And we're multiplying that by 100%. And I said, last time, if you want to put INC for increase, just to help you remember, that's great. Or you want to put P% or whatever, right? But what we're doing, we're increasing it by 30%. 100% plus 30% is what? 130% as a decimal. What's 130% as a decimal? Evan? Enough? Dayton? You're turned around? Okay. What's 130% as a decimal? Some new voices today. This goes back to our conversion objectives. Your Khan Academy for the past couple of weeks has been talking about this. Griffin?
1.3.
1.3. Okay. And you want this to be greater than a whole, right? Because you want to increase. That one whole takes care of the original 125. The 0.3 is going to increase it. Okay? And this will get you, spoiler alert, $160.50 directly. Okay? Try the next one on your own. It's a bowling score, an original amount of 180, and we want to increase it by 45%. We're going to increase 180 by 45%. I'll give you a couple minutes to do it two ways. The first way, any of your choice from the from CO24, and then the second way, use that formula. It's pretty nifty. All right, I think we're back. I don't think I broke it. Okay, so our goal is to increase 180 by 45%. However you did it here, that was up to you. Your answer should just match what we all get by doing the formula, by finding that new total directly. So our original amount is 180, and we're multiplying that by 100% plus the increase, which is 45%. Okay. To put it in your calculator, we're going to first convert this to decimal form here. So 180 times 145%, which is what we get from 100% plus 45%. As a decimal, that's 1.45. And what's your goal for your next bowling score? Colin?
Oh, I don't think I'm right.
Okay. What?
261.
261?
Dang it, I was right.
Yep.
Lexi, got that too? 261. Colin, you got that? Trust the math. Trust yourself. 261 for a bowling score. A lofty goal, right? And were you thrown off, Colin, because this number is so much bigger than 180? Well, keep in mind that 45% is almost what? Almost half, right? So what you're saying is you want to increase this by almost half. What's half of what 180? 90, right? And 261 is 81 greater than 180, so it fits, right? It fits. But it's good that you thought to question it, but then when you think through it, I mean, that's almost half. That's a pretty big gain there, you know? So, anyone not get 261 and not quite sure why? If you got 81 as your answer, you found the increase, but not the new amount. Your final step then would be to add 81 to 180 to get to the 261. Okay. The homework is the objective, yes. Quentin?
I don't understand
The formula? Okay, so let's go back to this. Okay, do you have that written down someplace? Write it down. Okay, now we're going to go to the backside where they're kind of pretty straightforward questions here. Okay. It says, below is a nightly report for a waitress at a local restaurant, or waiter, I suppose. Calculate each customer's bill after the tip has been added. So this initial bill, this represents the original amount, right? Then the tip is the increase. You're increasing the bill by a particular percentage. Okay? Following so far? So for Sophia, sorry, this is before I knew you preferred Sophie. So for Sophie here, right, her original bill is $23, the increase is 10%. So go to our formula. It was original times 100% plus the increase, right? The original amount is how much? 23. So we're going to start this with 23. Okay? We're going to take that times 100% plus the amount of the increase. What was the amount of the increase? 10%. Okay? Now, what's 100% plus 10%? 110%. So this becomes 23 times 110%. Following so far? Okay. Now to put this in our calculator, we're going to convert to a decimal. So what is 110% as a decimal? Right. And you can put the 1.10 on there if you want to. Okay, just to help visualize that. And so the answer to this is going to come from 23 times 1.1. What is 23 times 1.1? Yes, calculators out behind. Kate?
48.3.
It is not that. 23 times 1.1. Sophie?
25.3.
25.3.
Oh, that was after I added both of them together.
You don't want to add both of them together because using the formula gets you to the new total directly. Okay? And that should trigger alarm bells in your head. The fact that if your tip was only 10% and your bill was like double the original bill, that's not 10%, right?
So don't add them together.
Yes. Using the formula, you get to the new total directly. Quentin, does that help now? Okay, so for each of these then, you're just replacing the original with a new number and the increase with the new percentage. Everything else is the same. Okay, Sophie.
For the next one, do you just round to 12?
You round to the nearest penny. No, you don't want to round 11.99 to 12. Keep it as 11.99.
What?
Keep it as 11.99. Yeah. The only time that you should round is a final answer, and you should round to the nearest hundredth. So for this one here,
What about tax?
we're not doing tax right here. Okay. So for y here, for 11.99 with an increase of 13%, you ultimately end up with a calculation of 11.99 times 1.13. Right? And yes, that does give you kind of a larger number, but let's see if I can find a calculator here. You can just round that to the nearest hundredth. We are talking about money, so 2 decimal places is sufficient. And so you get 13.5487. You would round that to 13.55. Okay? 13.55, nearest hundredth. But no, don't round until your final answer. Because every time you round, you're losing accuracy. And if you can constantly round as you're solving it, you're going to lose accuracy every time you do. So save it for the end. Sir, Jack. You can use whatever you want to. The formula, I think, is the most efficient way to do it, to be honest with you. You know, it's just one calculation. Especially once you kind of get the hang of it, you get the pattern. You realize that 13%, 1.13, 10%, 1.10, right? Once kind of that clicks, then the formula is going to be faster than fractions or whatever else. Okay. Others that you're coming across that you want help with. Others, Tony.
On the other side?
Yeah, let's talk about that word problem on the first page here. Okay. It says, we'll do the first one. It says you purchase a calendar for $12 and pay with a $20 bill. How much is your change? The answer is not 8. It's not just 20 minus 12 here, because in the directions it does say to add 7%. Okay, tax is 7% here. I also reminded you that 7% as a decimal is 0.07 and not 0.7. So let's use our formula. We have original times 100% plus the increase. Carter, what's the original amount? It says you purchase a calendar for $12 and pay with a $20 bill. How much is your change? What's the original amount before tax is added on? What's the price of your purchase before tax? $12, right? Okay, and we're multiplying that. We're increasing it by 7%, which gives us 107% that we're multiplying 12 by there. And what's the decimal value of 107%? Lexi? 1.07. Right? Not 1.7. That's 170%. 1.07. Okay? 12 times 1.07. We are talking about money. So if this is, I don't think it's nasty actually. I think it's like pretty nice. $12.84. Okay? That's the price of the calendar after tax. $12.84. You pay with a 20. How much did you change? The price of the calendar after tax is $12.84. You pay with a $20 bill. How much is your change? Kylie. $7.16, right? $20 minus $12.84 gives you $7.16 change back. Right? Dane, turn around, please. Okay. So, another word problem, similar situation here. You're buying more stuff. You pay with a 50. Tax is still 7%. Then on the second page, we already talked about this, the customer, the bill, and the tip. The next section is just straight up increase an original amount by a percentage. Okay? Does say show your work. Do show your work. If you use the formula, write out the formula. Write out what you're plugging in. Okay? Then you've got another word problem, and then for review, you've got some conversion stuff at the end. But work must be shown. Okay? Work must be shown. Questions, comments, concerns, complaints, comments, congratulations, or criticisms?
Congratulations!
Thank you, John. Any others?
Merry Christmas.
Ooh, yes. Shay,
In the spirit of God.
in the spirit of Christmas. Very, very good. All right, that's all you math.